Hi everyone, good morning. Welcome to EEC 3013 Electronics 2 Laboratory number 7, entitled Digital to Analog Converter. Alright, so I will be showing to you how to do the simulation, no? Regarding this laboratory. Since we don't have any much time, so we will do the lab using the multi-sim. Alright. So let us figure it out. What will be the objectives of this experiment, right? So the objective of the experiments are determine the output voltage of a 4-bit digital to analog converter or DAC or DAC. Second, simulate a 4-bit digital to analog converter in multi-sim, of course, and build and measure a 4-bit digital to analog converter. All right, so here are the equipment required in this laboratory experiment. Now, of course, we need to have a multi-SIM. Okay, so multi-SIM power supply. So we have 10 volts, 10 volts, and 5 volts. Okay, all right, and we need a multimeter. Okay, a baud plotter, an operational amplifier, no, the 741 UA 741, and the resistors are R1 will be 25K, R2 50K, R3 100K, R4 will be 200K, and R5 will be 10 kilo ohms. All right, so here is the multi-sim circuit. So we're going to implement this, no, using the multi-sim circuit. All right, multi-sim software. All right, let's go to the multi-sim and connect this diagram, okay, or circuit. Multi-sim. I'm going to use the 13.0. Okay. All right. So if it happens if you don't have multi-sim, you can download this in the National Instruments website, no, and then you can register it as a trial version, no? So that you can download and use the multi-sim for 30 days. Okay. All right. So let us implement the circuit, no. All right. So we need a what component? Switch, no. One, two, three, four. Four switches. Okay. And four resistors. All right. So let's try to find these switches. Okay. So, okay. Switch. All right. So I think that is SPDT switch. All right. One. So we need four pieces. Okay. Right. As you can see, in our circuit, in our manual, the switch is upside down. No? So we need to rotate or uh, twist this one, no? From this position to the down position. So let's click this one, right click on it, and flip vertically. All right, there you go. And this one also flip vertically. This one also flip vertically, as well as this flip vertically. All right, so you have four switches, and now you need a resistors. Okay, so resistors. So just get any resistor. Then later we're going to change the value of that resistor. Okay, so we need five resistors, right? Oh no, four resistors rather. Then after that, you need a 741. Okay, 741, another resistor, and a battery. Okay, 741. All right, so let us look for this 741 op amp. Okay, this one 741. Okay, okay, let's place the 741 alone. Okay. All right, 741. And then we need also another resistor. Okay. How many resistors? Additional? Only one. Then a battery. DC battery, this one. Okay. This. Okay. Two batteries. All right. So one will be negative. So you need to rotate it. All right. This, no? As shown in the diagram here. All right. So now we need to connect all of this in the switch 1, no? Okay, these points, all of them. Right, so from there, so make here like this. Oh, sorry. Okay, now we flip it, no? So we need to flip it horizontally as well, like that. Okay, so don't forget. Flip it horizontally. All right, then we can connect. Right, then we need also another battery, no? From here. Okay, and a ground. From here, ground also here, and also here. Okay, now all of these will be connected here. So change this one to 5 volts. Of course, we need to connect this one to ground. And all of this connection, no? Connect it together as well. And connect this one to the ground, no? As per the drawing. Okay. Now, you need to connect this to the resistors, these switches. Okay. And change the value. So the value are 25, 50, 100, 200. So this one will be 25. This will be 50. This will be 100. Oh, sorry. And this will be 200K. Okay. Then after that, connect them all together. Okay. And connect it into number 2 pin of the amplifier. Right. And number 3 will be connected to the ground. Right. As well as this. Need to connect this one to ground also. Okay. Then the positive 10 volts will be connected to 7. So this one connected to 7. That, and this is 10 volts. Okay, as well as this. No? This is 10 volts. And connect this to number 4. Okay, for the negative power supply. Then your 10 kilo ohm, okay, this 10 kilo ohm will be connected to the number 2, no? Feedback number 2, and the number 6 for the output. Okay, then a voltmeter, connect to the output, right? and 1 for the ground. This. All right, I think we are good to go and we can do some simulation. But before that, let us go back to the manual and read the manual procedure. All right, so first you need to determine the output voltage. Okay, now we already know that the voltage, okay, the V3, okay, the V3 is equal to 5 volts, no? This one. Right? So you can say 5 volts divided by how much the R1? 25. So you need to calculate the currents, no? Currents of each. 25 kilo ohm. Right? So how much will be this? So 5. Okay, let's have the scientific calculator right here. Okay, so 5 divided by 25. Okay, all right. So that is 1, 2, 3. So it's zero point 0.2 milliamps. Okay, so this is 0.2 ampere. Here, 5 volts divided by 50 K. So how much this one? 5 divided by 50K is 0.1 milliamps. Okay, 5K divided by 100K equal to 5 divided by 100,000. No? 1, 2, 3, 0.5 milliamps. 0.5 milliamps. Okay. And last but not the least, 5 divided by 200K. That will be equal to how much? So 5 divided by 200,000. 1, 2, 3, 0.025. 0.025 milliampere. Okay, so this is your the results, no, of your currents, no, in each resistance value. Okay, after that, now you need to get the V out, no, the V out. Okay, V out is equal to I input, no, total current times 5. All right. Okay. Then after that, you need to get also, no, the equation, no, V out. This is for the digital value, no. We need to say digital value. This is either 1 or 0. So how to do that? So you need to sum all the currents, okay? Sum all the currents, no, I1 and the digital value of the switches, okay? So what are the currents, no? So for example, so currents, let's say this is 0.2 milliamps multiplied by S1, no? For example, no, our S1 will be, let's try this one, no? Okay, this one. So S1 is 0. So we can say this is 0 plus 0.05 milliamp multiplied by, now for the I2, this one, no? Then switch to also 0 plus 0. No, first is 0.1, sorry, 0.1. and is 0.05 milliamp times 0 again, plus, okay, plus I4 is 0.025 milliamp times the switch here, switch 4 is 1, okay, 1. So that will be equal to times the R5. R5 is how much? 10 kilo. 10 kilo ohms. All right. So let's calculate it. All right. So you can say 0.2, okay, or we can say 0. So wait. So here 0.2. This is 0. Okay. Plus 0.1 milliamp times 0. 0 plus 0.05 milliamp times 0. 0 plus 0.025 milliamp. Okay, that's equals to 0.025, no? Okay, 0.025. Okay, so that will be in milliamp. Okay, then times 10. Okay, 10. So 0.25, 0.25. Okay, all right. So here you say 0.025. 0.25. Okay, that's the determined value. Then after that, we will do the multi-sim value. So multi-sim value and measured value will be the same, or they are the same. Okay. So multi-sim value. Okay, let's run this. Okay, let's switch it on. 0, 0, 0, 1. Okay, that is how much? Negative 400, negative 247. Let us check. Let's verify it. No? Okay, so this is 247.444 millivolts. Or we can say, why is it negative? Because here, no, the drop across R5 equals to the output voltage. Okay, so which is negative with respect to virtual ground. All right, so it's natural, no, it will be negative. Okay, all right, so here it will be negative 247.44 millivolts, no, or this is 0 or negative 0.25, no, or 247 volts. Okay, so they are almost the same. Okay, by the way, this is also negative. Okay, from the formula, no, here, see, R, V out negative. Right, right, so it's almost equal. Okay, so the measured value will be almost the same, no, because we're not doing the actual, we're doing only the multi-sim value or multi-sim simulation. All right, so that's how you do it, no, for the measurement, for the calculation and measurement. Okay, if it is 0, 0, 0, 1, 0. Okay. How much the value? Negative 3.74, no? In multi-sim. Okay. This is negative 3.74 volts, no? In multi-sim. 0, 0, 1, 0. This one. Okay. But how to calculate? If you want to calculate it, use the formula, no? So 0, S1 is 0, this is a 0, so this will be zeros, and this 1, and this 0. All right, so here it is I3, no? I3 is 0.005, okay, 0.05. So you can say 0.05 times 10. So we have 0, uh, uh, 0.05 milliamp times 10. Okay, anyway, no, just calculate it. 0.05 times 1, that will be 0.05 milliamp times 10,000. Okay, 10,000. All right, so that's how you do it, and fill in the tables, and you get result. Now for the okay, since we are doing the multi-sim simulation, and we don't have the interview, no, for question and answer. So I would like you to ask us to answer these questions, no? So this will be my questions to evaluate you, no, for the question and answer of markings. Okay. So answer these questions. Write your answers here and here. So I prefer now this will be individual answers. Individual answers. All right, so please don't copy, no, from your group mate. So you can have the same values here, but the answers here at the student assessment should be individual. Okay, do not copy. So this one NA, no, so no need to do this. Okay, so until here, no, NA. Okay, so only answer this by using the formula and the measurement using the multi-sim. All right, so good luck. Thank you.